Random variable probability distribution and expected value. Example 1 says for the following set of numbers, find the mean. Well, the mean clearly tells me that I'm going to add all of these up. So we're going to add them all up. And then we're going to divide by the number of these in these, the number of all the values. So what am I saying? There's 1, 2, 3, 4, 5 values. So I'm going to divide by 5. So let's take 275, add it to 56, add it to 34, add it to 102, add it to 102. And when I do that, I get 569 divided by 5. And 569 divided by 5 is 113.8. And that is the mean for these set numbers. Example 2 says if the probability distribution for the random variable x is given in the table, what is the expected value of x? Okay, so we have this table given to us, and you got this formula here and information on it. So what we're going to do is we're going to find the expected value of x. All right, so we're going to take our x1, which is a -6, right? Times it to our pi, which is going to be for the first column. And then we're going to add it to the second one, which is 4 for x and 0.3 for p, plus the third one, 3 times 0.2. Now that I do that, we multiply the -6 times that 0.5, we get -3. We're going to add it to 4 times that 0.3, and we get 1.2. We're going to take that 3 times that 0.2, and we get 0.6. And then we're going to say -3 plus 1.2 plus 0.6 gives me a -1.2, and that is my expected value. Okay, example 3 says, in tossing 6 fair coins, what is the expected number of heads? All right, so we're going to create a table that represents the 6 tosses, and that's going to be my xi. So my value, we're going to start at 0 tosses to 1, 2, 3, 4, 5, and 6. And then we're going to find its probability for each one. Well, first I need to determine what is the total number, our total number of elements in the sample space. So we are talking about a coin, right? And coin has 2 sides. So let's figure that out. We know it has 2 sides, and we're going to do a total of 6 tosses. So I'm going to raise it to the 6th power. So 2 to the 6th power is the same as saying 2 times 2 times 2 times 2 times 2 times 2, which is 64. So now I know what my total number sample space is going to be 64. Now I'm going to find the probability at 0. Then we're going to take the number of the expected event, the elements in the event, divide it by the number of elements in the sample space. And when I start with that, I just got 1 over 64. So there's a chance of 1 over 64. Well, now let's find when the probability of 1. So we got to set up, and we could have set it up with this formula, but we're going to set up this formula. Remember the notation when we did combinations where we had N, R, where N was my total number in that that's going to happen versus at a time that it happens, which is R. It can also be written as CN comma R. Okay, so we're going to do CN comma R over the 64. Well, what is this? What is the N and the R for the CNR in this particular place? Well, N is going to be 6 because we're going to do a total of 6 tosses, and R is going to be 1 because we're talking about the one time that it's happening, and over 64. Well, I'm going to come down here. I'll have to scroll back up. I'm going to come down here and let's plug in our formula. Well, we know the combination formula is going to be N factorial over R factorial times N minus R factorial, right? So what is N again? It's 6 factorial over 1 factorial times 6 minus 1 factorial. So I'm going to write this as 6 times 5 factorial, and then we just get 1 times that 6 minus 1, which is 5 factorial. Well, the 5's reduce, right? So since they reduce, now we're left with 6. And let's not forget, we're dividing all this with 64. All right, so let's divide that by 64. Now this reduces by 2, and when we reduce it by 2, we're left with 3 32s. So in my table, I'm able to come up here and write 3 32s for that one. I really should have made my table bigger, or write smaller. I need to write smaller. Okay, so now I'm going to erase so I can use this space for when we have the probability of 2. I'll clean this all up just for a minute. All right. Let's scroll a little bit, maybe get off that bar. All right, so let's move on. And the probability is 2. Let's change this to this color. Now I got my C is going to be 6 for N and 2 for R, all divided by 64, which is 6 factorial over 2 factorial times N minus, or let's go ahead and put in what N is. We already established that one. 6 minus that 2 factorial, all divided by that 64. So now I got 6 times 5 times 4 factorial, all divided by 2 times 1. 6 minus 2 is 4 factorial. My 4's reduce. 4 factorials reduce. So now I'm left with 6 is 3 times 2 times that 5 all over 2 times 1, which I'm just going to have to list the 2. Leaves me with 15. And don't forget, we're dividing by 64. Gotta be careful and not forget about that because that can mess our answers up. And that doesn't reduce. So now I have 15 64s. Now let's figure out what happens when it's 3. Do this right quick. Give me some more space. I don't have to erase everything this way. All right. So now let's just change this. Let's go to green. So when I plug in 3, my N is still 6 and my number of times is 3. So now I got 6 factorial over 3 factorial, 6 minus 3. So that's going to be 6 times 5, 6 times 4 times 3 factorial, all over 3 factorial, and 6 minus 3 is 3 factorial. So I know this 3 and this 3 will reduce. I'm left with 6 times 5 times 4, and 3 factorial is 3 times 2 times 1. Well, I can reduce this 6 here, or I can write the 6 as a 2 times 3, and that causes the, whoops, my straight line didn't turn out so straight. Okay, that causes the 2 to reduce with the 2, 3 with the 3. And now I got 5 times 4, which is 20. And that reduces down by 4. 4 goes into 25 times, and 4 goes into 64, 16 times. So now I got 5/16. Okay, we're doing good. Now let's try when we have 4. For my R. Okay. Well, my N still stays at 6. R is 4. So now I got 6 times 5 times 4 factorial over 4 factorial, and then 2 times 2 factorial, because 6 minus 4. All right, so now I can mark out the 4 factorials, and I can rewrite 6 as 2 times 3, and then I'm going to multiply it to 5, because 2 times 1 is 2 factorial. And 2 reduces, and it leaves me with 3 times 5, which is 15. And this is my answer. So I got 15/64. So now let's do it when it's 5. Now don't forget that 64 if you're rewriting this over. Okay, now let's go to, let's do this one. Now we got 5 for my R. So I got 6 factorial over 5 factorial, 6 minus 5. All right, so I can say 6 times 5 factorial over 5 factorial. And it's going to give me 1 factorial. I can reduce these here, and now I'm left with 6 here, and the 64 goes right here. Oops. I just didn't write it each time, but just don't forget it. So now I got 6 64s. I'm going to reduce both of these by 2, and it leaves me with 3 32s. 3 32s. Now let's find out what happens when we're on our 6th row. All right. Now let's plug in. I know that my 6 is in and my 6's are, so I have 6 factorial over 6 factorial, 6 minus 6, right? We come over here and I have the 6 is actually the factorials. They've reduced, right? They reduced and left me with that 0 factorial, which is 1. Okay, 0 factorial is 1. So we kind of just went straight on down to this last step, and that's just, this is the answer, that's it. Okay, that's example 3. Now let's find out, now that we got our table established, let's answer the next question. We want the expected value, expected number of heads on this here. So now that I have all that information, let's apply this formula. And the formula here, the expected value, is plot. So we got our X value in the first column. We got 0 times that 164 plus 1 times that 3 32s plus 2 times 15 64s plus 3 times 5 16s plus 4 times 15 64s plus 5 times 3 32s plus 6 times 164. When we are said and done, our answer is 3. So the expected number of heads is to be 3. If you want to do the math right quick, we know this goes to 0. This 1 times this because you get 3 32s. 2 reduces with that 64, right here. Leaves me with 15 32s plus 15 16s plus the 4 and 64 reduces and leaves me with another 15 16s plus 15 32s plus 64 or 6 divided by 64 gives me 3 32s. Now my least common denominator is 32. So I'll have to change these two fractions to where the denominator is 32. So that means I multiply top and bottom by 2. And then I can add them all up and my answer comes out to be 3. Okay, let's do example 4. It says a pair of fair dice is rolled once. Suppose that you lose $13. So let's set up our table. So I got XI, I lose $13. It says that, and you win $20. And we have a sum of 5 or 4. The dice here. And let me go back and reread this right quick. Suppose you lose $13 if the dice sum is 3. Suppose you win $20 if the dice sum is 5 or 7. How much should you win or lose if any other number turns up in order for the game to be fair? So we are looking for let me get to that point. We'll get to the final point. First things first, we got to figure out what goes here and what goes here by determining the expected number of the rows, right? Expected number of times that you can get the 3 for the loss and then 5 or 7 for the win. So I'm going to call this A. Let's call it A. So for us to determine what is the possibility to roll a 3? Well, we know we can roll a 1 and a 2, or we can roll a 2 and a 1. So if we look at it right here, we have, well, first, before I go too far, let's talk about the dice. When we got 1 dice, we have 6 possibility dots, right? When we have 2, it has 6 possibility dots. And since we're rolling a set of dice, fair dice, 6 times 6 is 36. So this is my number of elements in the total sample space. So now when I roll these 2 dice, I know I can roll a 1 and a 2, or I can roll a 2 and a 1. So when we talk about this one here, we have 2 possibilities of getting the 3, right? So we have 2 possibilities of it. So now we're going to determine what goes here. So what I got to do is take this expected value and divide it by the total number of samples in that space. So my expected value over 36 reduces down to 1/18, and that's where I get this 1/18. I'm going to call this next one B. Let's call this B and C. So on B, the possibility of rolling a 5, I can roll a 1 and a 4. I can roll a 4 and a 1. I can roll a 3 and a 2 and a 2 and a 3, right? So is there any other possibilities? No. So this one has 4 possibilities, 1, 2, 3, 4 of getting it. And we're going to divide it by the total number of in the sample space. This reduces to 1/9. Now let's take C. What's the possibility of rolling a 7? Well, I get a 1 and a 6, or a 6 and a 1, a 5 and a 2, a 2 and a 5, a 3 and a 4, and a 4 and a 3. So we can roll this possibility. So we got 1, 2, 3, 4, 5, 6. So this is 6 out of 36. It reduces to 1 6. All right. So now what I need to do, since they're mutually exclusive, meaning there's no intersection, I mean, we're talking about a 5 and a 7 here, right? So we're going to use this formula. But remember that I changed the notation a little bit. I said, let's do B and C. Okay, so we're going to use that as a label. So I'm going to take the possibility or probability of B plus the probability of C. And we're going to add them. So I got 1/9 plus 1/6. And my least common denominator, we need to figure that out right quick. It's going to be 18. Oh, I don't know why I even had to think about it. 18. So it means I'm going to multiply top and bottom of 1/9 by 2 and top and bottom 1/6 by 3, because I need 18 in the denominator. So I got 18. 2 times 1 plus 3 times 1 gives me 5/18. So I got 5/18 here. And now we're almost there, guys. We're almost there. What we need to do now is we need to determine, we're going to have to solve for y. But we got to figure out what fraction goes in that column. So let's look at, let's look at that right quick. I'm going to erase some of this just so I won't have to scroll up and down on the page. So bear with me just a second. Let me get this all erased. All right. Okay, so now that I have this erased, now what we're going to do is we're going to take the 1/18, that probability, plus the 5/18 probability, and we're going to solve for the probability that it's any number, but the 3, 5, or 7. We're going to set it equal to 1 because we're talking about one row, right? So what I would do is I would add these two together first before I moved them over. And I noticed the denominators are the same. So I got 6/18. And I'm just gonna, just to save on writing, I'm gonna write P here. This reduces to two, hang on, let's do this right. 3 goes into 6, right? 2 times. 3 goes into 18, 6 times. Oh, it reduces even more. I don't know why I overthought that, guys. I overthought that. It happens. 6 goes in itself once, goes into 18 3 times, plus that P equals 1. Now I'm going to subtract that 1/3 from both sides, because remember what we do to one side, we got to do to the other. So now I get P is equal to 1 minus that 1/3. In order to subtract this, I got to have a common denominator, and I notice it's 3. So I'm going to multiply this 1 by 3 over 3. Now I got 3 minus 1 over 3, which is 2/3. So now we got 2/3 here. Now our last thing that we need to do, guys, is we're going to find that expected value right quick. We're going to solve for y. So let's set this all up. Set it all up to solve for it. So we're going to say the expected value, we're going to set it equal to 0. So I'm going to have 0 is equal to -13 times 1/18 plus 20 times that 5/18 plus y times 2/3. Okay, so I'm just gonna do a lot of cleaning up before I just move stuff around and start distributing. So I got that negative 13. I'm gonna multiply it to that 1/18 fraction. And it gives me a negative 13/18. And I'm gonna add that to 20 times that 5/18, which gives me a 50/9 plus that y 2/3. I'll set equal to 0. So now I'm going to take that negative 13/18, and I'm going to add that to the 50/9. So now let me make some more space right quick. All right, so now that gives me 0 equals 29/6 plus y 2/3. Let's subtract that 29/6 from both sides. What this is going to do is going to give me, it's going to give me y. So, and I'm just going to write this y first. So in order to solve for y, I'm going to multiply by the 3/2. I'm going to multiply the reciprocal because I need y to have a +1 coefficient. What we do to one side, we do to the other. If I notice that 3 goes in itself once, goes into 6 twice, now I have a negative 29/4. And let's put it in decimal form. 29 divided by 4 gives me 7.2. So the expected value here is a negative 7.25.